Hi everyone, welcome back to another video, and in today's video we are going to be solving some numericals. Okay, so in the videos before this one we have discussed certain concepts, certain equations. Okay, what we have not done is practicing numericals based on them. Okay, so that is what we are going to be doing in this video. Before starting, I will just give small tips and tricks as to how avoid getting the wrong answers. So nobody wants wrong answers, right? They just come uninvited. So my point being that sometimes the question can go wrong because of very silly mistakes that we make, and that is what I'm going to be addressing here. The first thing is the units. Okay, sometimes we don't see the units of the values that have been given to us, or the value that we have to find out, right? We don't see the units of that, and that is where we go wrong. Okay, so one tip which I used to always use, and which you can definitely use, is to always compare the units on the LHS and RHS. Okay, they should always be same, and if you're finding out that the units on the LHS and RHS are same, that is when you get some little some confidence ki maybe whatever you're doing is right. Okay, so for example, I'll give an example. We have C is equal to lambda nu, a very simple equation that I think you guys know already. So C is 3 into 10 to the power 8 meter per second, right? This is a constant, and everybody should remember the value of this constant. This is LHS, and lambda is in meters. Matlab, it can be in centimeters, it is a length, it can always be in the units of length, okay, which is meter, centimeter, kilometer, whatever, but generally it is in meter. Okay. The frequency, on the other hand, is in second inverse. Of course, it is a unit of time inverse. It can be in minute inverse, hour inverse, day inverse, but generally it is in second inverse. Okay, so if you compare this is meter per second inverse, and this is meter per second inverse. The units on LHS is equal to units on RHS, and that is how you will be comparing the units from now on. Okay, always keep comparing the units on every step, and also cancel the unit out if they are cancelling out, because then you will be arriving at an answer of a unit, and you can also check. So in the certain numericals that we do, I will show how you do that. Okay, but always keep units in mind, because they are going to actually help you a lot. Okay, because sometimes we make the very silly mistakes of writing the wrong unit, and the answer goes wrong, and it's not a good day for anybody. Okay, so having said all that, I will start with the first question. Alright, the first question says, so I have taken these questions from the NCERT textbook of class 11th, chapter 2, structure of atom. These questions are easily available. If you don't have a textbook, you can easily find these online. You can just download the PDF. Otherwise, you can also practice questions from elsewhere, as and when you like. Okay, so the first question is, calculate the wave number and the frequency of yellow radiation having wavelength equal to this. Okay, first things first, whatever is given to you, just write that down. Okay, so I don't think I'm the first one telling you this, because everybody, if you are at this stage and you're 11th standard doing doing your chemistry numericals, of course you know how to face numericals, right? So I think everybody does that. Just write lambda, which is given to you. This is 58000 angstrom. But something which I will also say is, stick to your comfort zone in life as well as in numericals. So of course, angstrom is not a unit which you're comfortable with. Okay, unless and until we're talking about psychopaths there. So okay, no more kidding. So of course, angstrom as a unit is not very comfortable, right? So we'll just convert it into a comfortable unit, which is 5800 into 10 to the power minus 10 meters. Okay, now also it seems like a little awkward, so we can just convert it into scientific notation, and this becomes 5.8 into 10 to the power minus 7 meters. Clear? So this is something which seems a little approachable and a little comfortable, right? So we have the value of lambda, or wavelength, in meters now. We have to calculate the wave number. So wave number is what? Simply the reciprocal of wavelength. Very simple. So just 1 upon 5.8 into 10 to the power minus 7 meter. Whatever answer you get after calculation, which of course you are going to do, I'm not going to do, is going to be in meter inverse. Okay, so that's correct. Alright, the second part of the same question says, also find out the frequency. Frequency is what now? I already have the lambda, which means I already have the wavelength. I have to find out the frequency. So C is equal to lambda nu can be the equation which I go for. C is 3 into 10 to the power 8 meter per second. Okay, I already know the wavelength, which is 5.8, this is 5, right, into 10 to the power of minus 7 meters, and nu is what I have to find out. So nu is going to be what? 3 into 10 to the power 8 meter per second divided by 5.8 into 10 to the power minus 7 meters. Okay, so meter and meter are going to cancel, and the answer that you're going to get after this division is going to be in only second inverse. ठीक है, and frequency का unit क्या होता है? It's second inverse or hertz, right? So which means it is correct with respect to units, and with respect to the answer, of course, it is going to depend upon how good you are at mathematics. Okay, so and it can also depend on one other factor, which is whether or not you have watched my video on logarithms, because that is also something which you can use if you are not very good at mathematics. So do watch that video if you want to, you know, solve big calculations without actually having to do calculations. Okay, so just do this, and whatever answer you get is going to be in second inverse, so that's correct. All right, the next question which we have is this: the Vivid Bharati station of All India Radio Delhi broadcasts on a frequency of this kilohertz. Okay, so we have a frequency which we already have is 1368 kilohertz. Okay, let's just be comfortable. 1368 into 10 to the power of what? 3 hertz. If you're not comfortable with unit conversions, I have made a video on that as well, so you can go and watch that, because you should, okay, if you're not comfortable. Otherwise, great. So this is 10 to the power 3 hertz. Okay, so we have this frequency in comfortable units. Calculate the wavelength of electromagnetic radiation emitted by the transmitter. So we have to just find out the wavelength. Okay, so very simple, I guess. C is equal to lambda nu. Lambda is nothing but C by nu. Okay, just put the values and you will be getting the answer in what? In meters. Okay, so I think you can easily do that and find the answer out. Okay, now and why are you going to get the answer in meters? I think I'll just write the units so that it's clear. This becomes 3 into 10 to the power 8 meter per second, and your frequency is 1368 into 10 to the power 3 per second. Per second cancels. The answer is going to be in meter. Whatever calculation you do, okay, that which you're going to do by yourself, is going to be the answer, and the unit is going to be in meters. Okay, now for only this question, I will just say that the answer is going to lie in, you know, it's going to be around 200 meters. Okay, it's not exactly 200, I think it's 219 somewhere, but after solving you will get the answer as around 219 meters. Okay, now if we just look at the physical meaning of it, it means that the wavelength, this is the wavelength, right? This wavelength is around 200, in the order of 200 meters. So it's quite high for a wave, electromagnetic radiation. This wavelength is quite high, right? So the next question he's also asking is, what part of electromagnetic spectrum does it belong to? Okay, now first of all, you're not expected to know the wavelengths and frequencies of all the different parts of electromagnetic spectrum, because we are not parrots, right? But of course, if this amount of wavelength is given to you, you should have an idea कि इतनी बड़ी wavelength सिर्फ radio waves की होती है. These are long radio waves, right? Only these will have that higher wavelength. Okay, and अगर तुम्हें इतना नहीं भी पता है, so this question is about what? It's about radio waves. It's going to be it's All India Bharati radio station. ठीक है, so of course they're going to be working in the range of radio waves, right? So even if you don't know the exact answer, you can also, you know, use your mind and find that out. But actually speaking, you will know that 1 meter से लेके इतना, this is quite blurred, but this is I think 10 to power 2 meters तक we have radio waves. ठीक है, so that is going to be a radio wave, because the answer is 200 meter. ठीक है, the wavelength is in hundreds, so it's going to be radio waves. Clear? All right, the next question is, calculate the energy of 1 mole of photons. Now as we have already discussed, energy, light, electromagnetic radiation. The energy of electromagnetic radiation is not continuous. It is present in form of packets, and one packet has the energy equals to h nu, or where h is the Planck's constant, having the units joule second. Okay, the answer is 6.6. The value is 6.63 into 10 to the power minus 34, and the unit is joule second, and nu is the frequency of the radiation that we are talking about. Okay, 1 photon will have this much amount of energy. 2 will have 2 into h nu, 3 will have 3 into h nu, 4 will have 4 into h nu. So 1 mole will have 1 mole into h nu. Very simple, right? So energy for 1 mole is going to be what? 1 mole, which is 6.02 into 10 to the power 23 into h, which is 6.63 into 10 to the power minus 34 joule second into 5 into 10 to the power 14 per second, because it's hertz, right? So per second and second are going to be cancelling. After solving, whatever answer you get after this long multiplication is going to be in joules, okay? And energy ka unit is joules. So units ke according you're correct, but mathematics ke according you're correct or not is going to be a toughie. Okay, so you can solve the answer, and whatever answer you're going to be getting is going to be in joules. All right, so this is the energy of 1 mole of photons. Okay, so all right, next moving on, we have this question: a 100-watt bulb. Okay, the power is 100 watt. Okay, so watt is nothing but joules per second. So you can use this instead of writing watt, because it will be easier when if you're cancelling out joules or per second somewhere. So you can do that. Okay, so power is given to me, emits a monochromatic light of wavelength 400 meter. So wavelength is given to me as 400 nanometer. So nanometer, not comfortable, convert it into meter. 400 into 10 to the power minus 9 meter, or 4 into 10 to the power minus 7 meter. Okay, so this is the power given to me, and this is the wavelength which is given to me of light. Okay, calculate the number of photons emitted per second by the bulb. All right, so this is a very simple question if we understand the question. Okay, the question is saying that we have the total power which the bulb is emitting, and we have the wavelength of light. Okay, we have to find out the total number of photons emitted per second. Now let's say you have 100 rupees, okay, and you go out to buy pens, okay, and you buy 10 pens, right? So you have 100 rupees and you bought 10 pens out of it. Okay, if someone asks you, how many pens have you bought? Okay, so of course, what will you do? You have 100 rupees and you're going to buy 10 pens, so 100 divided by 10, 10, which means you bought 10 pens of 10 rupees. Clear? I don't think that was very difficult mathematics there. Similarly, we have total energy as 100 joules per second. Okay, if I know the energy of 1 photon, okay, and I divide that by 100 joules per second, I will be getting the total number of photons that we are talking about here. Is it clear? I think this is very, very simple mathematics. Okay, so what we need to find out is, we need to find out the energy of 1 photon, which is h nu. Okay, h nu. So h we already know, which is the Planck's constant. Nu is something which we need to find out, and we don't have nu, right? We have lambda. So very simple, C is equal to lambda nu. Nu is nothing but C by lambda. So we can convert nu, we can find out nu by using this equation, and we can put this here. So energy will be equal to h, and nu is what? Nu is C by lambda. Okay, and you can put all the values. H key value you already know, C key value is 3 into 10 to the power 8 meter per second, and lambda is something which we just know, we are given in the question, and we will find out the energy. Energy is going to be, of course, in joules. Clear? Okay, so, and it's going to be in joules per second. Okay, because we are talking about in 1 second, right? So of course here we have 100 joules per second, and whatever answer we are going to be getting is going to be in division here. The joules per second and joules per second is going to be cancelling out, and you have a pure number. Since there's no unit, okay, no units means pure number, and we are finding the number of electrons, number of photons. Number of photons ka koi unit to hoga nahi, so that is going to be your answer. Clear? So if you have any doubts as to what I said in this particular question, you can just comment that down below, and I will post a total answer of this question if you have any doubts of that. But I think it's quite simple, it's not that difficult. Okay, once you understand the English of the question and the meaning of the question, I think that's when the question dies, and okay, that's when you can find out the answer easily. All right, the last question for today is this. Yesterday we did a topic called the photoelectric effect, and okay, and that is what we are going to be using today. So the total energy of radiation that we are providing to a metal, okay, that total energy is h nu, has two works, that is the threshold frequency, that is just ejection of electron, plus providing that electron with kinetic energy. Clear? So threshold frequency is given to you, this value is given to you. Okay, for a metal is itna, that is given to you. calculate the kinetic energy of the electron emitted when the radiation of this frequency hits the metal. So we know the total frequency also, and we know the threshold frequency also. H we already know because that's Planck's constant, okay, and this is what we have to find out. So simple mathematics, this is h nu minus h nu naught is going to be the kinetic energy, which we have to find out, right? H is outside, we have nu minus nu naught is the kinetic energy, right? H is going to be having the units joule second, right? So 6.63 into 10 to the power minus 34 joules second, and nu is what? 1 into 10 to the power 15 second inverse minus 7 into 10 to the power 14 second inverse. Okay, so just to perform, you can just perform this calculation. This is joules second, and this multiplication में second inverse में आएगा, second inverse and second will cancel, and the answer is going to be in joules. ठीक है, so whatever calculation that you're going to do, because calculation is simple mathematics and that you can handle. Okay, I have helped you out with the chemistry part of the question, and the mathematics part is, I think, quite easy to handle, and you can do that. Okay, so once you solve this entire thing, you will be getting an answer which is going to be in joules. So as per the units, you're going great, but as per your mathematics, it's going to be a toughie again. Okay, depends upon your skills and your calculation skills. Okay, so this was it for today. We have practiced the numericals for each and every type of equation that we have studied as of now, and I have only helped you out with the chemistry part of it. I have not yet helped you out with the mathematics part of it, because we are dealing with chemistry here and not with mathematics. So you can do that. Even if you need help there, okay, you can watch my video on logarithms and how do we go about using them. So you can do that, and if you have any doubts, of course, you can comment that down below. I will definitely help you out there. So thank you so much for watching.